My name is Nicholas Dille and I'm speaking to you from Freiburg near the Black Forest in Germany. And today I'll be talking to you about how to improve your container image builds using BuildKit. I am a DevOps engineer working for Haufe Group in Germany, and I'm working in a team that is responsible for maintaining the services for our development teams in the DevOps process. So I'm concerned with code repositories, with build servers and respective build agents, and with artifact stores and that kind of thing. I'm also an automator at heart, and I'm always trying to automate myself out of the job, but for some obscure reason that hasn't really worked out so far, but I'll keep trying. Okay, so let's first start out with a question what BuildKit actually is, and then take a look at what it offers for your container image builds. For example, it offers improvements to the multi-stage builds and the build cache. It offers an easier handling of secrets during your build, and it even can persist cache directories from one build to another. And throughout this presentation we will be using the Docker CLI, but at the end I'll show you how to use BuildKit as a separate component without Docker. Now, Docker comes with two build engines. The first one is the legacy build engine, which has been around since the early days, and it is the default when you run a Docker build command. But at the same time, Docker brings the BuildKit engine, which is a component of the Moby project, and it has already been integrated into Docker, but it's not enabled. But enabling BuildKit is as easy as creating an environment variable. So setting docker_buildkit to 1 will give you access to all the great features and improvements in the image builder. So for example, when considering image builds, I assume that most of you have already seen or even done their own image builds using a multi-stage build, but let's do a quick recap. So in a multi-stage build, a Docker file can contain multiple sections starting with a from keyword, and those are executed from top to bottom. And each section means that the commands are executed in the context of the specified image. And then it's possible to copy files to the current stage from a previous stage. And let's see how this helps in software development. So an important thing is that multi-stage builds help you to separate a build and runtime environment. Now, why would you do that? The build environment is usually something that you need to build or to compile your application. So what you need for that is a compiler. For example, in the Java world, this would be Java C as part of the JDK. But your build usually has a bit of tooling around it. So you usually have build dependencies, you usually have build tools, and all of this accumulates to a really large image. You can ship this large image, but it contains too much stuff that is not really needed to run the application. So consider a runtime environment with the minimal things that are required for your application. So for example, the runtime for your Java application, which is just JRE. And what you'll also need are the execution dependencies. And if you package all of that without the compiler, without the build tooling, you get a much smaller image, and a smaller image directly results in a smaller attack surface. Just think about the fact that it doesn't have a compiler to build source code into a new binary. The nice thing is that this separation of build and runtime environments already works with the legacy builder. So you don't need BuildKit for that. But when you add BuildKit to the mix, you get concurrency. So consider this Docker file on the slide. It has 3 stages, build 1, build 2, and final. When BuildKit comes across a multi-stage build, it will analyze the Docker file and create a dependency graph. And this dependency graph will tell it that the stages build 1 and build 2 can be run in parallel because they don't depend on each other. But the final build stage depends on build 1 and build 2. So the final build stage cannot be executed parallel to build 1 and build 2, but has to wait for the other 2 stages to finish before it can execute. Now, think of the parallel stages as downloading a tool, a tarball tool, then unpacking it and putting it in the proper directory, setting permissions. This could be done in one of the parallel stages, and the result is then copied to the final image. And this will be much faster than than the traditional build without concurrency. Let's take a look at this. So I've prepared a demo for concurrency, and we will be running the same build with a legacy build engine and then with BuildKit. And what we're running is actually the Docker file that you've just seen on the slide, but I've added a delay to the build 1 and build 2 stages. So both of these stages sleep for 10 seconds. And when using the legacy build engine, we'll see that it's executed top to bottom. So it will execute 2 separate sleep commands of 10 seconds, which accumulates to a wait time of 20 seconds. So the overall build takes nearly 28 seconds to complete. Now, if we do the same thing with BuildKit, it will, as you can see now, execute both sleep commands at the same time and therefore only accumulate an overall sleep time of 10 seconds instead of the double. So the build in the end finishes in just over 12 seconds, which is much faster. Okay, so you've all probably seen the build cache before. So if you run consecutive builds of the same Docker file on the same host, it will speed up because it will not have to redo everything but take stuff from the cache. But sometimes your build does not run on the same host. So consider our environment at Haufe, where we have connected multiple build agents to a build server like GitHub or GoCD, and you don't know where your build will end up on. So this means that you will not benefit from the build cache of a single host. But the legacy build cache already allows you to give it a local image to use as a cache. So what you have to do in your build is you pull the image you want to use as a cache and then specify the --cache from parameter. So when thinking about a pipeline with consecutive builds, you could always pull the last build of your image or the last build output of your pipeline and use that as a cache for the next one. But it's a bit, it's not so nice to pull the image first before using it. So BuildKit adds something very different. Instead of you having to pull the image, BuildKit is able to go out to the registry hosting the image and download the layers it can use for the build cache. So let's take a look at this. Okay, to demonstrate this, I am using a small local registry. And when using at the BuildKit powered remote build cache, what we need to do is we first need to enable BuildKit, and then we need to pass a special argument, a build argument. And this is picked up by BuildKit in the background, and it tells BuildKit to embed the cache information into the image before it is pushed over to the registry. So when the build is performed, it will run as normal with BuildKit. But at the end, the information about the build is compiled, and there's also a special message at the end. It says, exporting cache, preparing build cache for export. And this means that the image manifest has additional information about the build. Now, to demonstrate that the build cache is actually taken from the image still residing in the registry, we'll first clear the build cache by docker system prune, and then build from a cached image, from an image that is still in the registry without pulling it. So let's clear the build cache. And then, as you can see down here, up here it is. It is importing the cache manifest and doing that from the image, and then the stages or the build steps that it can take from this image are then not executed again, but taken from the image, and your build is much faster than before. Okay. The next important thing is handling build secrets. So sometimes it's necessary to go out to a protected host, let's say to download an installation package. And please don't do that by putting an env directive in your Docker file, because env burns a variable into the image. So whenever you run a container based on that image, you will receive that variable and will be able to see the contents. And if that someone is not allowed to see that secret, then you've effectively leaked it. So one option to work around this is using a build argument. But BuildKit offers something different, and this is that it's able to mount files into a container and mount those files temporarily using tempfs. Now let's take a look at how this actually works in a separate demo. And for that I've also prepared something, a demo to mount a secret, and we'll first look at the Docker file. So one thing that you'll need to do is you need to tell BuildKit that it's using a specific syntax so that there's support for something else, for something new in the Docker file. And then you're able to specify a parameter to the mount command, to the run command, sorry. And this will tell it that this run command needs a mount of the type secret and a secret with a specific ID. And then I'll be running a few commands to explore this secret. And I've also added a separate run command without the mount parameter to demonstrate that it's only available when you specify this new parameter. So when you then run the build, you need to tell BuildKit that there's a secret with a specific ID that is filled from a specific file specified in the source option. And when running the build, note I've switched the output to plain to easily show you the output. So up here we have the run command with the mount parameter, and you'll see that there's a separate mount point containing the secret that we specified in the Docker file as well as in the Docker build command. And down here we'll see that there's the file that we wanted and that it has a specific content. If you run a command without the mount parameter, then you will not receive a new mount point. So your secret is secure depending on where you put the mount parameter. Okay. But there's something else. BuildKit is also able to use a local SSH agent during the build. And this is meant to prevent something like the Docker file that I've put on the slide, which is a really bad example. So first someone tried to copy the SSH private key into the image, then connected to some host to do something, and then try to remove the SSH key. But what happened is that the image looked like the SSH key is actually gone, but it is still present in a lower layer because the copy command creates a new layer which contains the SSH private key, and a later layer is not able to remove it but only to mask its existence. So this is a really bad example, and please don't copy this. You can copy everything from my slides, but not this example. But BuildKit offers you something different. And I'm about to show you how this works. So in this demo, we will be using a local SSH agent and then connect our build to that agent to use the SSH key. So first we'll create a new SSH key and add this to a locally running SSH agent. So this is really quickly done. And all of you, please remember this short string, so you'll be able to compare this to the SSH key present during the build. And now we'll create a new Docker file. And this Docker file, again, has a special syntax. And the run command receives a special type of mount parameter. But this time, the mount is of type SSH. And then I've added a few commands to explore this. And again, a separate run command without the mount parameter to see what it looks like without the SSH mount. Now, when we now run the build, we need to tell it that we want an SSH agent connected, but we'll just use the default configuration which connects the existing SSH agent into the build. And as you can see in the plain output, just in a second, here we have the run command with the mount parameter, and we automatically get the SSH authsock variable, which tells SSH where to look for an SSH agent. And now this is the key that is available during the build. And as you probably all remembered the string from above, you can easily test that it's, or even easily check that it's the same string, right? Yeah, let's make this a bit easier. This is the key present in the local SSH agent, and now it's a bit easier to compare this to the one available in the build. As you can see, it is the same. Okay, let's switch back to the slides. Next topic. I told you that BuildKit is able to persist a cache directory. And as you're probably aware of, modern software development relies on dependencies. So you're actually writing glue code to for the dependencies in your package, because you're relying on packages that other people have created and have been thoroughly tested by the community. The downside of using all those dependencies is that you need to fill the cache with them. So, for example, your node modules will have to be filled with all your dependencies, and those can easily be a few hundred or even over 1,000. And BuildKit offers you to persist such a directory between builds. And let's take a look how this can be demonstrated. So first of all, we'll enable BuildKit for the whole demo. Now, next thing, we'll take a look at a Docker file that we are using to warm the cache. And again, it's using the experimental syntax, and it's also using a different mount parameter. This time the mount is supposed to be of the type cache, and the target directory specified which directory in the image is cached by BuildKit. So, and we will be creating just an empty file called foo.bar, and we'll check if that file is available in a second build. So first we'll run the cache warming Docker file, and this is rather straightforward. It creates the file in the specified directory, and then it's done. Now the second Docker file to check the cache has the same mount parameter for the same directory, but this time we'll just take a look at the contents of this directory. So, and as you can see here in step number 7, the mount parameter has mounted the previous cache, and there is a file called foo.bar in this directory, so caching has worked. Let's switch back to the slides. Now, so far we have been using BuildKit as part of the Docker CLI, or we have used the Docker CLI to execute stuff using BuildKit. But there are multiple ways how to use BuildKit, and I've created a table to show you the different types of options you have. So we've looked at the way a way of executing BuildKit using Docker, and you can use that locally, like I've just done. But you can also execute BuildKit using Docker in a containerized way, which is Docker in Docker. And some of you have probably heard of this. I'll not dive deeper into Docker and Docker because it has security implications, and I actually want to show you options with BuildKit instead of discussing security concerns. And there's also something rather new in the third column, which is called rootless, which is a way of executing container builds without a privileged container. So it's a way of mitigating the security concerns in a containerized Docker daemon. But what I'll show you is how to use the Docker daemon, the BuildKit daemon and the CLI locally without Docker. And I'll quickly demonstrate the Daemonless variant. So that is a script that is used to wrap the daemon and the CLI to make it easier, because as you'll see in the first demo, is that you need to run BuildKit, the BuildKit daemon, as well as the BuildKit CLI. But the Daemonless script takes care of running the daemon transparently when executing a build. So why would you actually use BuildKit without Docker? And the nice thing is that it gives you container image builds without the need of a Docker daemon. So your requirements for building a container image are much lower than your requirements when you use Docker to do this. So let's start off with using BuildKit locally, and we'll switch back to the demo. So we have a demo for running BuildKit locally. So first we'll run the BuildKit daemon, and normally we need to use sudo for this, so we need to run this as a super user. This should not have happened, but it's probably fine. So probably it was running from my previous test. So BuildKit is still running in the background, and now we need to run the client for this, which is buildctl, which is used to execute a build against BuildKit. And it has a different syntax than the syntax we know from Docker. So first we need to tell it what the front end is, so what the input file is that specifies what a build should do. And the front end now is the Docker file .v0. And then we need to give it the context, so that is the dot we usually use at the end of a Docker build command. So the directory which is packaged and sent over to the daemon as the build context. And then of course it needs to know where the Docker file resides. Now let's run this. And as you can see, this has run through. And so this is a way of running BuildKit locally. You start the daemon and then you can run build against an image build against it. Now, for the second one, I told you that there's a script to run BuildKit Daemonless, so a way of not having to start the daemon explicitly. So let's take a look at this. And let's take a closer look at this command. It's the same one if you've just quickly seen on the slide, but I want to go through it slowly. So we are running a new container, and it must be privileged because the BuildKit daemon requires to be run in a privileged way. I mentioned this a bit earlier. There's also the concept of rootless, so running stuff non-privileged. And that is something that's also already working with BuildKit. But in this case, I just want to show you how to execute a BuildKit build Daemonless. And it is executing the BuildKit container, but the BuildKit container will usually start the BuildKit daemon. And we don't have a chance to easily run the build then without a Docker exec into the container. So I've changed the entry point and changed that to the buildctl Daemonless script, which takes care of launching the BuildKit daemon transparently for me. So it launches it in the background and then passes on all command line parameters to the buildctl command. So and this is what the last part is about. And those are the things that we've just seen in the local demo of BuildKit. So I'm passing on the same commands or the same parameters over to the buildctl Daemonless script. And the stuff that it uses is mounted into the container from my local PC, from the local directory, into a directory called /src. And I've also switched the work directory to this /src directory to make sure that BuildKit is able to find everything in the right location. So, and of course, as always, the image is not present, so it will first be pulled down from Docker Hub, and then the build starts. And as buildctl doesn't know anything else about BuildKit, it tries to reach a local BuildKit daemon, and apparently it's working, so it has started the BuildKit daemon transparently in the background. Okay, so I've added a few slides at the end to show you how to transition from the traditional Docker build commands over to BuildKit, if that's the way you want to go. So one thing that we've already seen is that for a Docker build, we usually specify the file parameter, and we have to specify the context directory. And in BuildKit, you always need to specify 3 parameters to do a Docker image build. So the front end, the Docker file, and the context. But we've seen that already. But if you want to push an image to the registry, like a Docker push after you've done a Docker build, BuildKit works a bit differently when trying to do that, because BuildKit can do everything at the same time. So after building an image, BuildKit will give it a name and directly push it to a registry. As a result of that, it's a single connection from the BuildCTL client tool to the daemon to build and push an image. So, and the output is a bit more complicated. So you tell it, that you want output of type image, and then you pass it a name, and that you want to push this to a registry. So the syntax is a bit different from Docker, but it doesn't take that long to get used to. And yeah. Another thing that you would probably want to do once in a while is pass in build argument. And this is rather easily done. So it's an option that you pass on to BuildCTL using a --opt parameter, and then you pass the build argument as a name value pair. And you can pass multiple --opt keys to pass multiple build arguments. So if you want to give an image a specific name, we've seen that a bit earlier, because an image receives the name using the -- tag in a Docker build. But in BuildKit, if you want a specific name to be assigned to the image, you do that in the output option. And then this image is created with a specific name and is pushed to the registry. Now, as soon as you start pushing images to a registry, make sure that you always integrate the build cache information. So when you do a --export cache type equals inline, the image build will always package the information for the build and push that with the image into the registry, and the import cache will use the same information from the registry in the build. Okay, so what we've seen in this talk is that BuildKit brings many new features to image building. For example, it brings concurrency to multi-stage builds. It also helps you protect your secrets during a build using mounts and SSH agent forwarding. And it improves performance by persisting cache directories. The nice thing is that it works with Docker, with the Docker CLI, but it also works without Docker, running directly the BuildKit daemon and the build CLI. So everyone, thanks a lot for joining. I've added a few names of people to follow if you're interested in BuildKit and the stuff that is published around BuildKit. It was a pleasure talking to you. Have a lot of fun at the rest of DockerCon, and hope to see you soon. Goodbye, everyone.